Hi everyone, so this is me doing the practice mole problems, the 10 questions that are on the sheet. I'm going to be doing number 2, number 3, number 5, and number 8 are the questions I'm going to show you how to do. So let me get started by changing my colors and make it a little bit bigger for you. So I'm going to type the question. Okay, so number 2 says convert 5.35 moles times 10 to the 25th molecules of calcium dioxide to moles. Now remember that this does not allow us to do scientific notation, so this should be an exponent right there, so it should be 10 to the 25th. Okay, so I always want to start with my know, what I want and what I'm going to get rid of. Let me change my size. Okay, so what do I know from the question? Okay, times what do I want to find from the question? And what do I need to get rid of from the question? And let's just go over some reminders. Okay, so once again, the words are know, want, rid. What do you know you want to get rid of? And the moles in these questions are always going to be equal to 1. So, because this is a conversion, so we're converting from moles to something else. So the moles in front of the mole amount is always going to be 1. Okay, if it's asking you for molecules, if it's asking you for atoms, if it's asking you for formula units, that's always going to be your 6 times 10 to the 23rd, or 6.02 times 10 to the 23. So if it's asking you for molecules, and I'm writing very slow because it's hard for me to write, I'm sorry. So molecules, atoms, or formula units, that's going to be the 6.02 times 10 to the 23rd. Okay, so for each one of these. Okay, back again. I just wrote things real quick. So for all three of these, for molecules, for atoms, or for formula units, it always has to equal 6.02 times 10 to the 23, because that's the value of a mole. Just like 1 dozen always equals 12 donuts, right? So 6.02 times 10 to the 23 is always going to be the value of the amount of molecules, or the amount of atoms, or the amount of formula units. So whatever it is, a mole of anything is 6.02 times 10 to the 23. And the last thing you're going to see is grams. So if they're looking for grams, you have to look at your periodic table. Your periodic table tells you the mass of 1 mole of that substance. So that atomic mass that's on the bottom that we've talked about previously, okay, is going to tell you what 1 mole weighs. It's the same amount, but now instead of AMU units, it's in units of grams. Okay, so the periodic table tells you what the value of those grams are going to be. Okay, so let's look at this question now as soon as I write periodic table right here. If only my touchpad would work and I could write with my left hand, but I'm writing with my right hand, so you need to forgive that I'm not left-handed and I'm writing with that left hand. Okay, periodic table. So from this question, the know has to be some units that we have that we know the amount of, that we have units for, and we know what the substance is. Okay, so it says it's 5.3 times 10 to the 25 molecules of carbon dioxide. So that's what we know. We know we have 5.3 times 10 to the 25th molecules of carbon dioxide. So this is the amount we know. If you don't know a number for it, it can't be what you know. If you don't know the units for it, it can't be what you know. If you don't know what the substance is, it cannot be what you know. That's an ugly 5. Okay, that one's a little better. Okay, so 10.25, sorry, 5.3 times 10 to the 25 molecules of carbon dioxide. Okay, through magic, I just finished writing that. Okay, so we know we have 5.3 times 10 to the 25th molecules of carbon dioxide. I want to find the amount of moles. Okay, so I want to find the amount of moles. So that's going to go on top. That's my want, because it says I want to convert it to moles. Okay, so that's what I want. And what I want to get rid of is always what other unit is on the top. So my no is also what I need to get rid of. So what I need to get rid of is those molecules. I started with molecules. I need to get rid of the molecules. Okay, back again. So remember, now have the setup. Once you set it up, then you can put your numerical values in, because I always like the setup, so you make sure you put it in the right place. If you put the numbers in before writing the words, you might write the numbers in the wrong place and everything's going to be messed up. Okay, so Let me hide that so I don't have to keep looking at that. So the moles, remember, always equals 1. So my moles on top has to equal 1. My molecules always equals 6.02 times 10 to the 23rd. So 6.02 times 10 to the 23rd is going to go here on the bottom. It's a little messy, I'm sorry. And I don't have the space because broken. That one's really ugly. 23rd. There we go. So the molecules always equal 6.02 times 10 to the 23rd. Okay. And now we want to cancel out. So I'm going to cancel out those molecules because that's what I wanted to get rid of. Okay. So the molecules are gone. Okay. My answer has to be in moles because that was my goal. That was my want. Okay. And the top is 1. So I just don't even have to worry about this 1. Okay. So 5.3 times 1 is 5.3. What I need to start doing is the division. Okay. So I have 5.3 divided by 6.02. Okay. So I need to divide that first. Okay, so 5.3 divided by 6.02, and let me just do a quick little note about the the sig figures. So this one only has 2 sig figures, okay, and this one, 6.02, has 3 sig figures, okay. So what's less? 2's less, so my answer needs 2 sig figures. So when I divide 5.3 by 6.02, I get 0.880. So that's going to round off just to 0.8 because it's 0.88, and then behind the 8 is a 0. So that's just going to drop. Okay, so 0.88 is the 5.3 divided by 6.02. And then I want to divide the 10 to the 25th by 10 to the 23. And so when I divide scientific notation with the exponents, you subtract your exponents. So take the 25 and subtract it by the 23. So 25 minus 23 gives me 10 to the second. Okay, and my answer has to be in moles. But now some of you are saying to yourself right now, but Ms. Cotta, that's not right. When you taught us scientific notation, you told us the first number has to be between 1 and 10, and that's less than 1. It's a decimal. That doesn't work. Okay, so there's 2 things you can do. You can move the decimal to make it correct. So if I move the decimal, I'm going to do it with a different color. I want to move the decimal so it's after the first number. That's not a 0. Okay, so that's going to be the 8. So I move my decimal 1 place to the right. Okay, and that becomes 8.8. Okay, so it becomes 8.8. And then my number was small, so I subtract the space that I moved. And so it becomes 8.8 times 10 to the 1, 10 to the first moles. Okay, that's your option of keeping it in scientific notation. I actually prefer to just get rid of the scientific notation altogether because it's really just not needed. So if you look at your original 0.88, okay, it was 0.88 times 10 to the second. Okay, so if I take my 0.88, okay, and it's 10 to the second, so if it's a positive number, it's going to make my number bigger. So I just move my decimal over 1 place, 2 places, okay, and it becomes 88 moles. Okay, exactly the same answers I have down below, but not written in scientific notation. So 88 moles, or 8.8 times 10 to the first, either one's going to be good for an answer. Okay, just make sure you don't change it incorrectly and you make the number smaller. The number's got to get bigger because it had a positive 2 exponent. Okay, and that is number 2 of your questions. Okay, now I'm going to do number 3. So I'm going to head to a new page, copy the question for you. And it says, how many formula units of sodium acetate are in 0.87 moles of sodium acetate? Now, if you notice, there's not even a formula for sodium acetate. So I don't have to do anything with the periodic table because I don't know the formula for sodium acetate. Well, yeah, I do know the formula for sodium acetate, but I don't need to know it in order to figure out how many formula units it is. Okay, so I just start with my same thing. What do I know from the question? What do I want? And what do I got to get rid of? So remember, your know has to be a number, a unit, and a substance. Okay, and we have that. We have 0.87 is my number, and the 8.7 is in moles, and the substance is sodium acetate. So I have a number, 0.87, a unit, moles, and sodium acetate is the substance. And I'm just going to write SA like that and not write the whole thing because you're just going to sit here and struggle and watch it, or I pause it, and it doesn't matter. Okay, then we multiply, and what do we want from the question? Let me get rid of that one because that one's ugly. I'll put an actual line in there. It'll look much prettier. Look how much prettier that looks. Okay, so what do we want from the question? The question says how many formula units. So I'm looking for the formula units, and I'm not going to write this out either. I'm just going to write F.U, but not F.U, just F.U. You're welcome for that one, everyone. And whatever I start with is what I got to get rid of. So what I got to get rid of is my moles. Okay, it's a really looking ugly moles because my hand's starting to give up after I've on my second question already. So bear with me. Okay, and if you remember what I said from the last one, moles always equals 1, and the formula units has to be 6.02 times 10 to the 23rd, because that's how much a mole equals. A mole equals 6.02 times 10 to the 23rd molecules, atoms, or formula units. Formula units is just another way of saying an ionic compound. Okay, this is ionic because it has sodium. That's a metal. So this is going to be 6.02 times 10 to the 23rd. And now we're set up. So now, I always like to cancel out. So I'm going to cancel out those moles because that's what I started with and that's what I need to get rid of. That's the point of writing it in the rid part. They're going to go away. And my answer needs to be in formula units. Well, this one's not as bad as the last one because all I have to do is multiply across because I got 1 at the bottom. And you guys know you don't have to divide by 1. So I just need to multiply 0.87 times 6.02. So let me get my calculator out because I don't have these done. I'm doing it with you right now. Okay, so 6.02 times 0.87. Okay, that gives me 5.2374. But I need to look at my sig figures. Okay, so if I look at moles, my number of moles, I got 2 sig figures here. This one's got 2, but this one over here has got 3. What's less, 2 or 3? Well, 3 is less. Remember, these zeros in the back don't count. If it was a 0 in the front doesn't count. But if that 0 was in the back, then it would count. So my answer needs to be in 2 sig figures. So I had 5.23, so it's going to round off to 5.2. So 5.2. Okay, so I just have 5.2. And 10 to the 23rd doesn't have anything to multiply with, so it just stays the same. And this is going to be in formula units, or basically ionic. How many ionic compounds is this making? Now look at my answer. You know that a mole is 6.02 times 10 to the 23rd because I've played that song for you twice now, I think. Don't worry, I'll play it again next week because I know you miss it. So if I look at what a mole is, this is a little bit smaller than a mole, right? It's not 6.02, it's 5.2 times 10 to the 23rd. So it's a smidge smaller than a mole. If you look at what you started with 0.87 moles. It was a little bit shy of a mole. So that's why my answer makes sense. This answer is a little bit shy of being a mole. So then I just say to myself, this works out. I know I'm on the right track. Okay, so that is number 3. Next, I'm going to go to number 5. So I'll go to a new slide and type the question for you. And notice I'm picking different types of problems. So I'm doing different types of problems so you have a guide to do one, and then hopefully that can help you with the other one. So I'm doing one of a different type. So the first time I looked for moles, the second time I looked for formula units, and this time I'm looking for grams. So each one has had a different goal at the end. Okay, and this one says convert 3 moles of As2S3 to grams. So arsenic sulfide to grams. Okay, same thing. What do I know? What do I want? What do I get rid of? And my know's got to be a specific amount with the unit and a substance. Well, that's my 3 moles. So I have 3 moles, 3.00 moles actually, and those are all significant. So that first 3 is significant and those 2 zeros are significant. So that has 3 significant digits. And this is moles of arsenic sulfide, As2S3. Okay, so now I can write this properly as I can with the non-working hand and a non-working touchpad. Okay, so As2, wow, that turned out ugly. Sorry it turned out so ugly, but hopefully as long as you can read it and understand what I'm writing. Okay, so that's what I know. What does the question want me to find? And what do I got to get rid of? Well, it says convert 3 moles of As2S3 to grams. So I need to find the grams. That's my want. And my rid is whatever I started with. And I started with moles. Okay, so moles has got to go on the bottom. Okay, so my answer will be in grams. And now I think, what does Ms. Cotta say? Moles always equals 1, because this is conversion. So moles is always going to equal 1. Grams has to be whatever it is on that periodic table. So I got to do some breaking down of this formula. Okay, so what elements do I have in it? I've got AS, okay, and I have S. I didn't spell this one out on purpose, people. It just came out this way. I didn't do it. And then I want to look at the formula and go, okay, I'm making 1 mole of this substance. If I'm making 1 mole of this substance, okay, how much in the formula do I need? So I need 2 moles of arsenic to make 1 mole, and I need 3 moles of sulfur in order to make this formula correct, to make 1 mole of arsenic sulfide. And then I got to look at my periodic table to figure out what's the molar mass, because the periodic table tells me what 1 mole of that substance weighs. So anything on periodic table, polar table, I was reading molar and I turned it into polar. So anything on the periodic table is going to tell you what 1 mole of that substance weighs. So there's no conversions you have to do or anything, but you have to remember now it's not an AMU anymore. The units are grams. So if I look at arsenic, it's 26.9815. So I'm going to round it to the first decimal place. So it's 26.98. So that 9 is going to round up to a 0 and become a 27.0. So we're going to multiply this. So it's going to be 27.0 grams because it's 26.98, and that rounds off to the first decimal place of 27. And sulfur is 32.066. Okay, so 32.066. It would be helpful if you had a periodic table open while I did this so you could look at it. So if it's 32.066, that 0 has a 6 behind it, so that's going to round up to a 1. Okay, so we got 27.0 and 32.1. Okay, I want to multiply them, so 2 times 27 is 54.0 grams. Okay, and then 3 times the 32.1 is going to be 94.3 grams. And I'm doing this in my head, so if my calculations is wrong, you're going to have to email me, because I'm really not doing calculations for multiplying a 3-digit number by a 1-digit number. Just like I'm not going to use a calculator to add this up. Okay, so I've got 148.3 grams is the molar mass of 1 mole of As2S3, arsenic sulfide. Okay, so I want to drop this back into my formula. So this is the amount of 1 mole of arsenic sulfide. So I put this number in, 148.3 grams. Okay, so now I have my grams in there. Okay, and now I want to cancel out. Okay, so I want to cancel out the moles, okay, because that's what I'm getting rid of. And I need to multiply the 3 times the 148.3, and then I got 1 on the bottom. I'm not going to worry about the 1 on the bottom because anything I divide by 1 becomes 1, okay? But I do want to worry about my sig figures. So if I look at the first one, let me change this color to purple this time. Okay, if I look at this one's got 3 sig figures because all of those are significant. These zeros are significant because they're trailing. This one has 4. What's less, 3 or 4? Well, 3 is less, so I need to round my answer to 3 places, whatever that answer may be, because I haven't done the math yet. Okay, so 3.00 times 148.3 gives me 444.9. Okay, 444.9. So I got to round that to 3 sig figures. So that's going to be 4, 4, and then that last 4 is going to become a 5 because it has a 9 behind it. So it's 445 moles exactly is how much we're going to put this answer on. Okay, and that's your final answer. Oh, sorry, I said moles. I'm totally wrong on that. That's my fault. I didn't look at my units up here. It's not moles because I canceled out my moles. This is 445 grams. Okay, don't forget what units you have on top of the want is the answer you have to have at the end. Okay, and that is number 5. And let's go to number 8. Okay, and the last one says convert to 8.00 times 10 to the 20th. And so remember, this is not giving me exponents, so I need to change that, to an exponent. So it should be 10 to the 20 molecules of H2 to moles, and there should be a little 2 at the bottom. Okay, so let's set up our know what we want and what we're going to get rid of. So what do we know from the question? What do we want? What are we going to get rid of? Okay, and I know from the question I have 8.0 times 10 to the 20th molecules of H2. Okay, so 8.0 times 10 to the 20th molecules of H2, hydrogen gas. Okay, and what do I want? I want to convert this to moles. So moles is going to go on top. And then I got to get rid of something. Whatever I start with is what I want to get rid of. Oops, and I forgot to write molecules over there. So that would help if I wrote molecules, but I didn't. So I'm going to write it right here. Because I forgot to write molecules. I think I was trying to avoid writing molecules because it's really long and my hand doesn't work. My hand's like, this is your fourth problem. Are you done yet? Almost, hand, almost. Yes, I talk to my own hands. Okay, so I have 8.0 times 10 to the 20th molecules of H2. I want to convert it to moles, and I started with molecules. That means I got to get rid of molecules. And what you should be thinking to now is, okay, now I need to add in my numbers. What did Ms. Cotta say about these numbers? Okay, the moles is always going to equal 1. The amount of moles is always equal 1. So my molecules is going to wait. So the moles is 1, and the molecules, 1 mole equals how many molecules? 6 times 10 to the 23rd. It's a 6 with 23 zeros at the end. Much too big a number. You're welcome. So 6.02 times 10 to the 23rd. I would act the same way in class. You know I would. I would still be singing to you. Okay? So our setup's complete. We have 8.0 times 10 to the 20th molecules of hydrogen, and we want to know how many moles that is. Okay? So always I want to cancel out my units first. So I'm going to get rid of these molecules because they're going to go bye-bye. Okay? And the top has a 1, so I don't need to multiply by 1 because multiplying by 1 keeps the number the same. What I need to do is divide my top by my bottom. So 8 divided by 6.02, and I want to keep in mind sig figures. So let me go in purple and talk about sig figures. So if I look at this one, it's 8.0, so he has 2 sig figures, and 6.02 has 3 sig figures. So my answer's got to be in 2 sig figures because 2 is less than 3. Okay, so 8.0 divided by 6.02, so I'm punching it into my little calculator, and that gives me 1.328. It gives me a lot of numbers, but I just want it in 2 digits, so it's 1.32. It's got to be 2 sig figures, so 1.32. Behind the 3 is a 2, so I'm going to drop that 2 and just make it 1.3. Okay, so 1.3. Then I want to divide 10 to the 20th by 10 to the 23. So remember what I said before. When you divide exponents, you have to subtract. So 20 minus 23, this is a 20, sorry, that would be a negative 3. So that's going to be subtracting the negative 3 it gives me there. So this can be 10 times negative 3, and my units are moles. Okay, you can leave this in scientific notation, and this scientific notation is correct because this number is between 1 and 10. So if that number is between 1 and 10, I'm good. Okay, this answer is fine. If you want to get rid of the scientific notation, then take your 1.3, okay, and you got to move your decimal place. Well, I have a negative 3. If it's negative, remember, I don't like to be negative. That's going to make my number smaller. I'm going to take money out of my bank account. So I want to go 1, 2, 3 spots, make a new decimal, fill in these empty spaces with zeros. Sorry, this wasn't my neatest writing ever right there. So it's 0.0013 moles is it out of scientific notation. Either one is fine, either one is correct, but just make sure it's whichever one you choose, you write it in the correct formula or correct notation. Okay, and that's it. So I solved 4 for you. You have 6 other problems to work on your own. If you need help, contact me.